the free weight and post weight is significant. Can we do that? From what we did last week.
I have to slow down a bit. But I'll still go on with some of the things we are doing. But you will do the theoretical aspect in the inference class. So first of all, anorexia is in what package? Mass. So what do you have to do? You load it. So please let's load it. How are you going to do the test? Chord or test. So you can do question mark what? Chord or test. And then you have it on the right. Then you can copy. Then come and paste. Or you can choose what we did last week. And then you paste it there. And then you'll be able to. That way. I'll just go around and be checking what people are doing. It's not loading. If you need help, you let me know. So first of all, load the package mass between the pre-weight and post-weight. Let's just test whether there is correlation. So it means that we are checking whether the correlation is equal to 0 or not equal to 0. Let's see if, so for now, when you do, I'm going to talk about the p-value as well. And Dr. Isa will also explain it better for you when you do the theoretical aspect. Who is that? One person. Okay, so you must copy. When you are done, copy the results. Go to R. That's how. Sorry, go to where. That's how you will be doing your assignment. I think next week I won't be around for 2 weeks. So you will be doing assignments. Once you submit, then there will be tutorial. Without submission, go tutorial. That is the same call. But we say question mark call of test. So it's just around the same thing. So question mark and start finding call. No, yeah. They're right. No, you don't. Just put the place at the nose. It's okay. Right. So that's it. You can read that. That is. That's how. can now begin to explain what is or interpret what you've done that. So you should do it the other way around. Since the interval does not include zero. But the interval is random, but the zero is constant. Are you done? Whatever results that you get, you must copy it, go to where, and then you do like insert a table, only one column, and you paste it inside. Yes. Only one column. Yeah. Only one. You can delete the one of the column. Or just go back. Just go back and read. Okay, let me demonstrate. Are you? That's fine. So you can run it. So now you must copy this and open it. So let's see. Let me now. So what is your conclusion? Conclusion from the results you got. It's not equal to zero. Why is so? There is no zero in the interval. Okay, so the interval does not include zero. So what does that mean?
It means the three ways and postulates are positively correlated.
They are positively correlated. They are correlated. Yeah. We can actually test whether they are positively correlated alone. That's different from what you have done. What you have done, it can be negative or it can be positive. But
the correlation value.
okay, yeah, I will explain. Let me also do my own, and then okay. So this is what I say you should do. Call.test. That's the function to use. So usually do it like this. So you have it on your right. Okay. Then you can copy. So this is it. So I copy all of it like this, and then you fill in. Okay. So how do I fill in? I begin. X. What is my X? Anorexia. So I have not. You see, I have not loaded mass, so you won't see it. But if I have mass loaded like this, and I start typing anorexia, I'll get it. So anorexia, it comes like this. I select, right? Then I put my $sign. It's pre-weight that we want as X. Okay. Then I go to Y. I can clear this one down so that I start typing anorexia. I slow down a bit. It comes. I select. Okay. Then I put the $sign. The next one is your post-weight. Good. Then the alternative. So let me explain this. Please, let's look over here. See, the two-sided means not equal to. So it can be negative or positive. That's what I made you do. But if I want to do what is over there, H1 less than 0, then it means the alternative, I need to delete all of them and leave what? Less. That means it will test whether the correlation is less than 0. And you were saying it's positive, so I may also be checking whether the correlation is actually positive. In that case, I'm not going to do this. I'm going to do H0, rho is equal to 0, as against H1, rho greater than 0. So this, in the alternative will be odd, greater. We'll do that. Okay. Here, it will be odd. What about here? Less. Good. What about The other one will be odd. H naught rho is equal to 0, H1 rho not equal to 0. So by default, it uses this one because that's the first we see over the two-sided. So what we did is this one. So the results, we are going to interpret it as not equal to 0. In other words, there is correlation. We cannot say outright whether it is positively correlated here. If we want to test that, then we'll use which one? This. In other words, the alternative will be greater. So those are the three alternatives we have in that system. Is everybody okay? So in this case, what but we are now going to situate what we are doing in the objective of the exercise. And then we will choose between one of them, which one we actually need to test. Is everybody okay? Yes. Yeah, when the problem comes, it will not come with the alternative. You, as an analyst, need to infer from it, from the objective of this exercise, what will be the alternative hypothesis. So let's read about the exercise. So I go to the help, and that will be help for what? Anorexia, right? Okay. So let's read it. So this is the anorexia data frame. It has 72. It's what? Weight change data for young female anorexia patients. So these are people who are unable to eat or they have eating disorders. And they are being given some treatment. What will be the end product? To see that whether there will be what? The change should be what? Improve. Okay, so we expect it to what? Improve. We will actually come to, you do this in the statistical inference. We will actually test a hypothesis to see whether the increment is actually significant. But that's not what we are doing now. Is that okay? We will call this paired t-test, and you do that, the theoretical aspect. So I don't want to jump the gun. You do the theoretical aspect. What it means is that the paired one, you measure before and after. Okay, so I have students in, I do an IA, and then I do a final exam. And I want to check whether there have been an increase, their performance have increased, or their scores have increased from their previous IA score. So it means each student that I take, I have your IA score, I have your exam score. It is different from when I take two different classes and I'm comparing their IA scores in, let's say, the evening school as against the weekend school. You cannot be in the evening and still be in the weekend school at the same time. So we call that independent. The samples are independent and so forth. So this one we are talking about paired samples. We can even continue. So they can measure after 6 months whether the gain you have made in your weight. Then we do it after 1 year and so forth. When we do that, we say we have repeated measures. So if you hear of repeated measures, it's just, the same person, the same unit, we are taking repeated measures on them. So notice that's also another form that the independent one, well, I can take 3 classes. So maybe the evening school, the weekend school, and the MPhil class. So in that case, I have 3 groups. And when we have 3 independent groups or more, we refer to the test that we use as analysis of variance or ANOVA. So if you hear of ANOVA, it is nothing more than comparing different independent populations to see whether the averages are the same. or not. But you will take all these, and we'll do all that here. But I want to delay a bit so that you do the theory, and then we can now come to it. That's the one. But I'll show you how the tests are conducted. Okay, so let's do my own. So now, here I cannot really choose the alternative. If they all increase in weight, what do we expect will be the relationship? It will be positive. Yeah. But it's not clear cut, because here, you see, it's not that increase here, because this one is constant, this one is constant. I'm just measuring. But if you increase in weight to the next level, and we all get the same, let's say, if they get the same increment, that's not even yeah, we will get some positive correlation anyway. But if some increase, others decrease, then the correlation may be close to what? 0. And so forth, vice versa. Okay, so let's just deal with the this one, the two-sided. So it means I can delete all this, the greater end, to leave this one. And even because it is 1, I don't need a C. You get it? I don't need a C if it is just 1. If it is 2, then I need combined function to do it. Good, yeah. So this I can delete, but you have to be careful when you are deleting this, because if you delete a comma, it will not work. So when you are deleting anything, you have to be very careful and delete as you should. Then there's also a method. Remember the correlation, we have Pearson, we have the non-parametric versions, Spearman, Kendall. R is able to calculate all of them. So if you choose the Pearson, it's going to use the actual values to compute it. If you choose the Spearman, it's going to use ranks. And also the Kendall also uses what? Ranks. And so forth. Okay. So that as well, if you leave it like this, is by default, it will use what? Pearson. But if you want to use Kendall, you need to delete all the rest and leave on Kendall and so forth. Okay, so let's move on. Okay, exact, we don't need it, so I can take it off. But confidence interval is necessary. You see, by default, we use 95. But I can also test at 90 degrees. Sorry, 90%. Okay, or maybe 99%. The health industry, that is life and death. So 5% of 30, if it is Ghana, 5% of 32 or 30 is much, right? Yeah, so they usually would take it at a higher level. The margin of error is very small. So usually maybe they would do like 99%, in which case they leave 1% as what is outside. Now, in that case, this must be changed to what? 0.99. So the 0.95 is what? 95%. So that's the confidence level. But default, that's what we use. But you have to be mindful in your sector where you work. If they use a high level of confidence, you must not use the default. So this is the default value. Okay, so that's the comment.
95 is the default one.
Yes, because usually that's what is used. But in the health sector and other high profile sectors, they may put it at a higher level. Okay. Continuity and so forth, we don't need it, so I can delete it. Look at the way I delete it. I delete only what is inside the parentheses. If you delete the parentheses, you find problems. Yeah, so that's our way. Once you master all these traits, you won't make mistakes when you are, working. Okay, so I can do this now. I can run it. When I run it, I get the results like this. I think we all found the results like this, right? Now, how do you report it? You cannot take out and go and show your boss, right? You need to write report. So the report should be in Word. Or later on when we train you in LaTeX, you can do it in LaTeX.
that to remind you that we will break along the way. Maybe the 10th week or 11th week, when we are getting to revision week, we will break like 2 weeks so that we train you in LaTeX. And then after that, when we come back, we are coming to do the exam. What do you want? Take home. Some take home, so don't take you home. Like salary. Yeah, so we will write exams, but it will be very simple. Simple is relative. What is simple to you may not be simple to someone else. Okay, so yeah, but there will be some training in LaTeX. You pay something small, so please. If you don't want to come, then you stay at home but it's good we all do it, especially with presentation, so that when you go to your workplace, when you get your presentation, that everybody will be looking at it. Yeah, so we won't use PowerPoint. Usually when we do presentation here, we don't use PowerPoint. Yeah, we train you in LaTeX, and then you'll be able to use LaTeX to do the presentation. But we'll take about 2 weeks to do that. And we'll do it on weekends so that everybody can participate. Yeah. Whether I'm done. Oh, just now. When am I supposed to close?
6:27.
10 minutes. Okay. So this is how we report. Okay. So when we are doing our reporting now, put the codes in a box, right? It's better. Then it makes it. We can distinguish it from what? Our narrative. So I do this. Please, let's look here. So this is the result. Okay. If I want the codes as well, I can also put the codes in. So I go to insert table and then only one. Then what code generated this result? So I'll go to R and pick this. This is the code, right? This one. So I'll paste that over here. Okay. So this is the code that generated the result behind. So I can just say this is a function to conduct. Hey, you can't see, sorry. Okay, so function to conduct the hypothesis testing or hypothesis test on correlation. So I write that. Now within this, you see when you take any of the books that I have the codes and the results are different from the font you are using. So usually we write with Times New Roman, right? So this will be Times New Roman, maybe 12, right? So you go here, you change this to Times New Roman. But this must be different. What we use is Courier New, and that makes it distinct. So you can type Courier, there it is. So you see, when you take books, this is how you will see it. There. So you see it's distinct from whatever we are writing over here. So when we are doing this, always we will put these ones, the ones in the box in what? Courier New. And then all our narrative will be what? Will be Times New Roman. Okay. So now, so conduct a correlation test, hypothesis test on correlation coefficient. Okay. Then I can now say results. So I put my results here, which is that. Then I must now interpret. So maybe interpretation. Hey, I have a meeting. Interpretation. Is that the spelling? Interpretation. Okay. So what is my conclusion? Well, I'll say that the 95% confidence interval for the correlation coefficient between, you see, I'm speaking in terms of the problem at hand, between the pre-weight and post-weight of young anorexia patients is, I can copy this, right? Or is, let's say 0.11, right? Two decimal places. 0.11 and all, 0.52. So that's this. Oh, okay. Then I can conclude that since this interval excludes 0, in statistics we always say we, meanwhile it is only you. We conclude that there exists what? Significant relationship between the pre and post weight of patients. Okay. So that's how you communicate. So you see, there are no, in the interpretation, I'm not putting in too many statistical jargon. Let it be in such a way that everybody will understand what you mean. Okay. And lastly, as I said, Dr. Isa will also teach you. There's another way of concluding, which is this, p-value, if you've heard of it. That is the strength of evidence we have against the H-naught. Okay? So if it is small, we reject. If it is greater, we reject. So what is the criteria? The criteria is this. We reject H-naught if the p-value is less than the alpha. What is the alpha? That the alpha is, you see, I said 95%. My alpha is now 5%. Okay? That's in layman's terms, the margin of error you tolerate, right? That's it. So if my p-value is less than that, I'll reject the null hypothesis. Other than that, I retain it. So if you look at what we are doing, the p-value is very small. So what do? You reject the null hypothesis. What did we do over here? We rejected it. So whichever one you use, it goes like that. But in reports, when you are doing this, you record the p-value and maybe if it's confidence interval, it's okay. But later on, you also do what we call the t-test, as I said. I don't want to go there because you do the theoretical aspect, otherwise people will not understand what it is. But at least you've done this, so you know that one. What I'm adding is the p-value. So the criteria is this, and you will do that in your inference class as well. So you can write this, that it says reject H-naught if p-value is less than alpha. And this alpha is usually 5% or 0.05. Okay. So that's what we use. But remember that I said you can change the confidence interval or your confidence level. If you change it, it will go with the alpha. Yeah. So here, if we look at it, since the p-value is less than 0.05, what do? We reject the null hypothesis. So that's another way of stating the first part of this one. So instead of saying the 95% confidence, I'll say that since the p-value is less than 0.05, we reject the null hypothesis of what? No correlation. In other words, there exists what? Some correlation between, or dependence. There's some relationship, linear relationship, as we should say. To be specific, linear relationship.
Is there a difference between saying there's relationship between the two variables
Yeah.
and there's a significant relationship?
Yeah. Okay, so in statistics, we talk about significance. Statistical significance, that's why we put it over here. So if there's a relationship, statistics will check whether that relationship is significant or not. So once we do a test and we reject, then there's this significant. That's why we put it there. Any question on this?
The last one.
Yes.
The sample estimate.
Yes.
One has 0.33.
Oh yeah. So if we do the actual correlation is 0.33, which means that is moderate positive. In other words, as this increases, you expect it, but it's not so profound. Okay, so we can draw or plot the graph to see what it will look like. You see there will be a gradual increase as one increases, the other also increases. I'll put this on your page for you to, the word one, so you shouldn't worry about it. But let me just do this and then we can, I'm sure Prof will come in and suck me in now. Okay, so how do we do this? Remember, what should we use in order to get a plot of this? Post-weight and we use plot. Is that okay? This is bivariate, so you need plot. As soon as I said it. Okay, so let me quickly demonstrate this, right? So this is it. Oh, not too good. Okay, so let's do it and see. So what can you see? You see there is some sort of gradual increase, but you see that's what we are witnessing. It's not that, it's not like it's a straight line, sort of. So you don't expect much correlation between this. But if you look over here, you see that as the pre-weight increases, there's some gradual increase in the post-weight as well. And that's what we only got 0.33. If it is 0.9 there about, you realize that there will be some linear relationship in there. Okay. So I think that should be it. We'll meet tomorrow and then we continue with it. You want to see the Asaki? You want to snap it? Okay. But I'll put it on your platform. Okay. All right. So enjoy the rest of your stochastic process. But I also run away to